Welcome to our Amphitheater Hot Shop and our live stream with our special guest artist. Let's give it up for Elliot Walker. Let's give him a big, big round of applause. Keep it going for his partner, Beth Wood, over there. We've welcomed Elliot to our studio here yesterday. This is part of his prize package for winning Season 2 of Blown Away. Let's give it up one more time for him for that. He did excellent work on that reality show. So we have our home team that's going to give Elliot and Beth a hand creating a really, really neat sculpture out of glass. We've been piecing together some of the components throughout the day, but I want to introduce Helen Tegler and George Kenner. Let's give them a round of applause as well. Dan's going to be doing some video work, and Amanda's over there. She's going to be moderating our online content. So this actually is live stream. Now, you folks aren't going to be recorded, but what you see up on the monitors is. So that is being broadcast to the internet. But I'm going to talk you through the process. My name is Chris. I'm also one of the glassmakers here. I'll jump in when they need me. But we're going to give Elliot a chance to talk a little bit about his work and what he's going to put together for you all today. So, Elliot?
Hello. So it's really nice to be here after a 2-year delay in this residency for obvious reasons. So it's really nice, and thank you all for coming, and thanks to everyone for watching online. So I'm currently moving in a new direction with my sculpture and giving myself a new conceptual focus. So as a full-time artist, I have quite an unusual relationship with the idea of work and the concept of work, but it's something that I've been thinking a lot about recently, and my new conceptual focus is, in fact, the idea of work. So the sculpture that we're going to be making today, that we've actually been setting up to make for the past 2 days, is called the Unbroken Back. And you can see a little sort of diagram of the piece there. Essentially, it's a human vertebrae and pelvis, which has this impossible loop in the middle section of the spine. So as human beings, you know, we work an awful lot, and we work really hard, and we work with our bodies, and we work with our minds. We work day in, day out for most of our lives. And then we get a few years of retirement, and then that's it. This system that we've put in place for ourselves isn't for our survival anymore. You know, it's not an evolutionary necessity for our survival. It's something we've built together to create this society that we have. And I think from a lot of people's point of view, you know, this is the way it is, but the system is a little bit wrong. It's a little bit twisted. We've all assigned ourselves to it, but it's not a natural thing for us to be working in this way. And this sculpture is basically meant to symbolize the fact that even though we've put these enormous pressures on ourselves as human beings and on our society collectively, that it hasn't actually broken us down. You know, we do it still, we do it continuously, and we pass this idea, this worth ethic down to our children. So this sculpture, the first in this series, is trying to sort of symbolize that strange relationship that we've built up about work. So we've made a few elements of this sculpture already. As I said, it's taken us 2 days to get to this point, and we had a little bit of a run through yesterday, which you can see here. It's quite ironic, really, because the unbroken back is actually broken. But you know, you have to go through this to learn, you know, to learn the different parts of the process, and hopefully we've learned enough to make it successful, a second successful attempt. So each of these individual vertebrae have been sculpted individually by hand by the team and myself, and each section is slightly different. You know, I've tried to keep this with a certain element of realism for the sculpture. So we have 12 of these central sections, these central vertebrae, which are sitting over there in this kiln, which we made this morning and yesterday. And the first part of the sculpture we're going to actually create in front of people today is this loop. So this loop is going to be built up of 12 of these individual vertebrae. We've already created the next section, and that's sitting in the kiln ready to put together. And then after we've created the loop, we're going to start working on the entire sculpture and putting the whole thing together. So I'm going to pass back over to Chris, who I think will be narrating the process, and we're gonna crack on and try and make a success of this second attempt. Thank you very much.
All right, let's give it one more time for Elliot Walker. Very good. I always like to ask, who here has seen glass blowing before? Just show of hands if you have. Who's seen Blown Away? Only a handful of people. All right. Well, Blown Away is a reality TV show. You can watch it on Netflix. There are 2 full seasons and a Christmas special out available. And spoiler alert, Elliot was the winner of season 2. That's why he's here with us for his residency with his partner, Beth. But they have both come from England, so they joined us yesterday morning, and their residency lasts until next week. So we worked all day yesterday, all day today. They have all day tomorrow. They'll take a little bit of a break Saturday, but then Sunday, Monday, Tuesday, they'll be working with our team. So he talked you through a little bit of the process of how he's been making some of the components and how he did the trial run for this one yesterday. It was really exciting. It was awesome to see it come together. We were able to salvage some of it after it broke, but I have no doubt that this one will be successful. So we'll get right down to business here. I'm going to talk you through the hot shop that we have. We have a lot of equipment. We have our main piece of equipment that George is standing next to. This is where everything really begins in a glass studio. That is our melting furnace. Now, the type of glass that we're melting here and working is called soda lime. It's really a pretty common one. And I'm going to talk a little bit more about it throughout the process through the show. But in that oven, we have a big ceramic crucible that's full of molten glass. And the temperature is holding steady at 2,100 degrees Fahrenheit. And we melt a clear glass. So the piece that you see on the table, that's what's in our furnace. It's going to look orange through a lot of the process because it's glowing quite a bit, but it does emit that light, and that orange will kind of dissipate. It'll come and go. But he's going to begin, I think we're making one of the vertebrae right now for this component, and he's got a blowpipe. He's just cleaning it up a little bit. Now, when we work on these blowpipes and we're done with the pipe, there's residual glass left on them. A lot of that glass actually shatters off as it cools very quickly. But some of that glass stays on there. So if you want to start off with a nice clean blowpipe, you do what he's doing. He's kind of heating the end, and he's pulling a little bit of that residual glass off of there. But you're going to see him use primarily this workbench. So he has all of his sculpting tools. He has the rails. He has that blowpipe he can set on the rails and turn the piece back and forth. But here he goes for our first gather. So when we dip into this oven, there's a big ceramic pot full of glass. And we can actually see the head of the blowpipe dip into that. There's a shadow on the surface of the glass when the pipe meets it, and we can tell when we're about to make contact. You dip the head just under the surface and you turn very smoothly, and then you raise the pipe level. That's called gathering. Gathering glass at this temperature is a lot like trying to get table honey out of a honey jar with a dipping stick. It's the same viscosity. Now, we can turn the temp up or down, but that 2,100 degrees is a really good mark for us. Many different tools can be used to shape glass. Can anybody tell me what he's using in his hands? Shout it out. Newspaper. Thank you very much. Folded up wet newspaper. Pretty common, pretty basic, something you see in almost every glass studio that people utilize. And it's a lot of layers. So over on this bench, we have pretty much the same set of tools. You can actually see the backside, still see the print. This one's kind of dry. We haven't used this today, so you want to wet it first before you use it. But for glass blowers, that's pretty much our hand. That's as close as we get our hands to shaping the glass. So this will turn into one of the vertebrae. He started a little bubble. So he gathered that glass, he shaped it, put a breath of air in there, and started a little bubble. He's not going to make this very thin. Say he wanted to make a wine glass out of this. He could blow that up to about 2 or 3 times the volume, probably the size of a medium grapefruit, and it would be really thin. It'd make a nice, delicate cup. But for the vertebrae, we want to have some stability to these. We want to have some structure to them. So not just for one, he could make one really delicate one, but we have to think that we're going to add these. We're going to build a spine out of these. And you want to have some substantial weight to them when you start to add them, so you have some thickness and a lot of strength and durability to it. So he's already planned all this out. And again, he talked about how we made a bunch of these yesterday that are sitting in those pickup ovens. But this tool that he's using, these are called jacks. Jacks are one of the most versatile tools. You see a lot of smoke coming off from the metal blades, which is beeswax we put on there as a lubrication. It just helps the tool to glide. Now, there's generally 2 ways to soften the glass as we're working it. A reheating furnace, we're going to see him use that quite a bit. But when sculpting glass to get really good detail, this torch, we call the hot torch, works really, really well. Now, I know all torches are hot, but we have 2 torches. The other one, we call the fluffy torch, and that's a propane flame. When you pull the trigger, it might be around 1,500 Fahrenheit. The hot torch will reach almost 4,000, so that's why we call it the hot torch. But there's oxygen mixed in with natural gas. And it's a great way to spot heat very specific areas. So once we start to sculpt detail, you can use that hot torch to really make sure you're only getting soft heat in one small spot, and you can keep the other details that you've already worked. But he's got the basic profile of the first vertebrae. He squeezed in a little groove into that cylinder, almost creates something that looks a bit like a yo-yo, or sort of a butterfly profile. And George's going to bring him this bit that we create these sections out of. So this is an added bit. And this is a really particular setup that we have to go through this. Now, George has done plenty of these with Elliot throughout the past couple days here. So he has a nice gather of glass that he let it kind of just stay round at first, but then he flattens it on our metal table. This is called a marver. Kind of creates a T shape. Now, when he gets this a little reheat, it's going to bring it over to Elliot straight up and down. That T is going to droop. So we need two little parts to kind of touch down on the vertebrae, the body, and then Elliot will cut that free. And this is a very tricky bit to deliver. But again, remember, the whole team down here, lots of skill, lots of experience. Now, hot glass sticks to hot glass very, very easily. Great close-up shot there, Dan. Elliot cuts it free. Now, he doesn't want those two sort of fingers, if you will, to touch in the middle because they'll actually seal together. He wants to keep a void there. He wants to keep an opening. So if you can see in the vertebrae that I'm holding, we have that little opening right there. So we're going to maintain that opening as Elliot starts to tool this and make some pinches and a couple pulls and do some contouring. George at times will hold a little metal rod right in that void to avoid those two from pinching together. But these steps have all been well rehearsed. You know, yesterday morning, Elliot and Beth were here ready to go, and they hit the ground running, and we started making these. He had a plan. He had this in his sketchbook. The same thing we see in our whiteboard right there. So he knew exactly what he wanted to do and how to do it, and we got right down to business. But this is our reheating furnace, this empty oven, and this one right now is set to just below 2,000 Fahrenheit. That can be turned up or down very easily. It's an empty oven, so the temperature changes very quickly. But 3 sets of doors, and once this piece gets bigger and bigger, when we start building it, we'll make use of all those doors, I'm sure. But let's talk a little bit more about the pickup ovens. So the ovens that have been holding these vertebrae, we have 2 of them going right now. These are top loaders, so we can open up the door, put the pieces inside. And right now, the one that Helen's standing next to has all the independent vertebrae. Now, earlier today, we put a bunch of those together to make one section of the spinal cord, and that is sitting in this other pickup oven. But at 900 Fahrenheit, our glass is rock solid. It's totally rigid. So the point of using these ovens, you can make all these components one by one. You can join them into a section. You can put those pieces away into a pickup oven that basically babysits them, keeps them at the right temperature where you can pull them out when you need them. What happens if you let glass cool too quickly? Anybody know? It breaks, it cracks, it can shatter. Soda lime glass is very prone to thermal shock. So when we're done making anything, we're going to put it through a very slow cooling process. That's called annealing, and the annealer that we're using today is right over here. Now, we've already put one piece in there, and that's holding at 900 degrees. When we're done today and this piece goes in, we're going to run the program on that oven, and it will slowly come down to room temperature. That's the annealing process, keeps things from breaking. But when you're making components, you can keep them in secondary ovens, these pickup ovens, and when you need them, you can pull them out. Now, before you pull them out from 900, because if you pulled out one of these vertebrae at 900 degrees and you hold it at room temperature for even 30 seconds, it's going to crack. 900 is a little too cold for that. So we can turn these ovens up to about 1100 Fahrenheit, give them a little extra time to soak that heat into them. Then you can pull them out, and you have, say, maybe 30 seconds to hold on to it and put it on the piece, and then you're good to go. If you turn the ovens up a little too soon and you let them stay at 1100, the glass can actually start to slump slightly, so you can distort its shape. Or what would be bad as well is the ceramic plate that's on the bottom that they're sitting on. that ceramic and that glass get too hot and they'll stick to each other. So the timing of turning them up is an art form in itself. And that's something you learn by working glass and working with this type of glass for a long time. So we start to learn the rhythm to it, essentially. So he's got that vertebrae complete. I missed it, but I saw the after effect. They just spooled a little hot glass around it, right? He didn't put it on the vertebrae. He put it on what we call the moil. Now, when you gather glass on the end of a pipe in this case, there is glass that's attached to the pipe. That's going to turn into scrap in the end. That won't be part of the sculpture. But that moil, you need to keep it hot enough when everything's attached to it. Because if that gets too cold, cracks can form on the moil, and then the piece can drop right off. So we don't want that to happen. So that moil wrap, they just added just a little extra heat there. But I think George turned the oven up a little bit. I think we're getting ready to start adding a couple of these together. And this is a really fun process. Now, there's a lot of ways you could do this. When you go to stick two pieces of glass together, you can use what we call a glue bit, and that's the process that Ellie's going to use. Or you can use our torch. You can actually soften areas with that torch and then stick and weld the pieces together. But he's using a little gather of glass. I think Helen will be the one bringing those over. And you'll see them drip it onto the form he has. And then he's going to hand the pipe off, quickly grab one of those vertebrae from the oven, and stick it right on that glue bit. And this is how we're going to build this form. But it looks like nothing's really happening. He's just waiting for the temperature to really get to where it needs to be with that pickup oven. If you rush this, you can crack those pieces, and you don't want that to happen. But I think we're getting pretty close. You're going to see him use some Kevlar mittens. So the gloves that he's put on top of the oven, just for quick grab, quick placement there, those are Kevlar, which is a really good insulated material. You can grab a hold of a 1,000-degree piece of glass with those, no problem. All right, so here we go. Now, to attach the glue bit, Elliot opts for tipping his piece right up in the air. We're going to use a little bit of gravity. We're going to let the glass kind of flow onto that vertebrae. And he's got a specialty shear in his hand. They're called diamond shears. He grabs a hold, aims for the center, drips it on, and then he'll cut free what he needs. And then he hands off the pipe to Beth. Beth takes it for a very brief reheat. Gives Elliot time to grab the gloves. He preheats the gloves before grabbing that. That's a really smart move as well. Even though those gloves are probably 80 degrees, that's cold to 1,000. And then he attaches it, lines it up. Nicely done. Let's give him a round of applause for that. Very smooth. One down. About 30 more to go. Now, he's also preheating these tweezers. So when Beth takes this, now the combo, the two pieces stuck together for a reheat, he can get in there with the tweezers and push it or bend it and start to make the contour, the beginning of the curvature that he's looking for. But those metal tools pull heat from glass very, very quickly. And if you grab that thin little section of that vertebrae with a cold tool, it cracks it, right? So he preheats it with that torch. That's another smart move. So let's get my terminology right. Elliot put up a drawing and a nice diagram this morning for us. So we've got the body of the vertebrae. We have the articular process, these little pinches right here, the spinious process, and then the transverse process, this outer one. But again, this is the form that we're shooting for. Now, he did make the neck portion of this already. So again, yesterday he made a bunch of vertebrae because there's a lot of legwork, a lot of time that goes into that. So he spent at least a couple hours making the vertebrae that were needed for the neck, and we actually put them together this morning. That's been resting safely in that pickup oven, and it has just a nice, easy arch to it. He'll assemble the loop, and I think then the base. Now, this part is already complete. So the coccyx bone and the pelvis bone, he did those in 3 parts with 2 vertebrae, and that's not going to be joined hot. So that was the decision that he made, but that piece is done and sitting in the oven, and it's ready to assemble when everything is all said and done. And there's a lot of ways you could choose to assemble it. I don't know what he'll choose, but here we go with vertebrae number 3. Now, there's always communication that's happening in a glass studio as well. Now, this is Elliot's piece. He's the one in charge. A big team of glassmakers out here, but he's in charge of orchestrating things, the rhythm of how the reheating happens, or the position of the piece, or who takes a hold of what, when Helen brings a bit of glass to him, when George opens the door. All these things are being orchestrated. Now, we've been working with Beth and Elliot the last couple days, so we've gotten pretty used to it. But still, we look for cues all the time. It might just be a little nod of the head, might be a little hand motion. There's all these little subtle signs that we're looking for. When a glassmaker goes into this oven for a very brief reheat, we're generally not softening anything. This is called a flash, or a flash heat. And this is really important. You can't let any part get too cold. Even though those glue bits that were just added are still soft enough, you go in for an overall, a flash heat, to maintain temperature throughout everything. That's really important. You can still see a little yellow tint, though. That is a tiny bit of light that piece is emitting, just a little bit of light. This view that you get into our oven, this is one of the really neat things about our program as well. That oven, again, is set to just under 2,000 degrees. There's a camera safely mounted behind it. It's not exposed to that intense heat, but there's a small window of fused silica glass. That's a specialty glass that can withstand close to 4,000 degrees without anything happening to it. Yeah. It's a glass type that was created here in Corning. It was engineered in 1934. But the soda lime that we're working, much, much lower melting temperature range. So you see the same kind of moves, right? It's almost like a dance, this choreography between the team. Elliot takes the piece, puts the bit on there, quickly hands it off to Beth for a reheat, gives them time to grab the gloves, give them a quick flashy heat. Then by the time she gets back to the bench, he's got the piece locked into place. Great. Elliot, is this going to be the loop then? Yeah. You're making the loop right now. Okay.
Yeah, so we're starting to offset the
Yep. And this will get put away, and then you'll start. All right, I'm with you. So he'll make the loop section, and then we'll put this away into one of the pickup ovens. Then we're going to start off on the final handle, and he'll make, I think, a couple, maybe 2 or 3 vertebrae. We'll attach the loop to that, and then we'll attach that neck component to it. Again, there's a lot of different ways you could approach this, but it requires a lot of planning, a lot of thinking ahead to do this, and he's got it all in his mind already. But if you watch as he's doing this, he's not only just starting to create that curve, but if you're looking straight down it, he's also beginning to offset them, right? Because to make the loop, you have to have it come out a little bit, otherwise it's going to tag back onto itself. So a lot of planning going into just that, just the placement, the really subtle adjustments, each one he's stacking on. Now you could go back in with that really high-powered torch and heat up certain areas and bend them if you need to, but if you do that, you start to soften the other sections of those vertebrae, and you don't really want to distort those. So really just working with that glue bit they're adding. Now, whenever you see Helen, in this case, bringing the bits over, she gets the same quantity of glass each time. That really helps Elliot with consistency. But she does the same positioning. She gets right above the piece. She gets really close proximity, but then she kind of goes loose-handed, lets him grab a hold of the shears and do all the steering. So he's the one doing the aiming. Great close-up shots there, Dan. Also notice every time Beth moves back and forth with this piece from the rollers that we call the yoke up by the oven to the rail on the bench, you barely even hear her set that pipe down, right? If you just bang it on anything or you set it down too hard, vibration goes through and that piece can pop right off before you're ready. Now, we're counting on that when the time comes, but obviously you don't want that to happen too soon. So really, really light-handed each time. You can see up in the cameras right now, the end of the pipe where the moil is really tarnished, very dark, but where Elliot's holding on to it, pretty shiny. These are all stainless steel, not a good conductor of heat as far as metals go. So when we're using these, we can hold on to usually half or 2/3 of the pipe. Now, if we're working on something for a long time, or say the level of glass in the furnace drops and you have to dip the pipe deeper in, the heat will work its way back up further. Here we have a nice pipe cooler, so we can set the pipe right on this little trough, pump it full of water, cool it off. Can answer any questions at this point. And if anybody online has any questions too, feel free to type them in. Amanda's here moderating all that activity, and she'll field them our way. Now using this torch, our fluffy torch, this is where he's allowing certain areas to lose heat, but he's keeping other areas warm enough. So it kind of stabilizes or balances the temperature out. That torch isn't really used to soften the glass, but just to maintain temperatures. The furnaces are powered with natural gas, but that torch is a propane torch. All right, so next vertebrae coming up. Yes, go ahead. How much will the end piece weigh? Well, if it's about the same as this one here, this one fell apart into 3 sections. The one section I'm holding on to, which is probably about 1/3 of the whole thing, this feels like maybe 10 pounds to me. So I'm going to guess maybe 25 pounds in the end. The pipe that they're working on right now is probably about a 20-pound, maybe a 15-pound pipe. But you have to remember that you can't grab all the way down. So if you had like a shovel full of snow and you held back weight here, it does feel like it's a little bit more weight than it actually is. We did have a question about adding things to glass online, and I'll talk a little bit about color as a preface to that, because this is all clear glass that we're working with. Most studios will melt clear glass, because when you have clear, you can add different colors through the process very conveniently. There's many ways to do so. Now, you can melt a colored glass as well, but say you melted a nice, pretty blue glass, and you have 1,000 pounds of it. You're not going to make anything but blue until you empty it and add something different. So a pretty convenient method is to use what we call frit, and this is just one application. Frit are little chips of colored glass that's produced. We buy this from a different company. They mix up their own raw materials, the silica sand, soda ash limestone, and add different metals in oxide or chloride forms and create colored glass by melting different metals into it. But the frit, if I dumped this into a big pile on our table or into a metal pan, you can take a gather of clear glass, roll it through the frit, it will heat up and stick, and then you can melt it all in that way. The company that we purchase our frit from, and bar as well, this is another format, it's color rod or bar. It's over in Germany. It's called the Reichenbach factory. They've been making color for almost 200 years, and there's roughly 200 colors that they produce, which is pretty awesome. And it's very convenient. We just go online and we type in whatever we need to order it, pay for it, they ship it out. But you see the constant back and forth, right? We never stay away from that reheating chamber too long. Lots of back and forth, lots of trips from the bench back to that oven. You can hear the burners too, kind of kicking up a little bit higher now that we've opened the door. Open the door on that oven and the heat drops a little bit, so the burner compensates, or the thermostat control on there compensates for that and kicks a little bit more air into the burner. So there's forced air mixed in with natural gas. But since those are empty ovens, the reheating chambers, we shut them off at night. We don't have to have those running all the time. We come in the morning, we light up shop, usually around 8 o'clock, and by 9, they're hot enough to work out of comfortably. Melting furnace is different, though. With all that glass inside that ceramic pot, you gotta keep it hot. If you came in the morning and it was even down to 1,500 Fahrenheit, still pretty hot, but if you go to dip a pipe in there, it's just gonna hit the glass. You won't actually be able to submerge it. If you imagine getting a jar of honey and putting it in the refrigerator for an hour, pulling it out, the viscosity changes quite a bit. The worst thing, though, and this is generally why you have to keep those furnaces running, is that the glass is shrinking as it's cooling. And if that glass inside that pot is shrinking, it's pulling on the ceramic and it will crack. It will break the pot. And that's really bad. But you notice all the different angle changes that we've gone through. The very first bit that Helen brought over, they dropped it straight on, from straight up and down. But now that we have this almost like a elbow joint going on that bend, Elliot's actually tipping the piece the other way. But really positioning it exactly where he needs to get that bit in the proper place for it. It also becomes a bit more challenging in this case for Beth when she's taking the reheats, because not just the extra weight that's being added on each little vertebrae, but it's now offset, right? So she still needs to turn and she still needs to flip so the piece just doesn't continue to slump. But the more offset that weight gets, the more torque you have to apply to turn and flip the piece. So it's interesting. Elliot was talking about, the concept of this being back-breaking work, right? The unbreakable back, to the loop in the spine in terms of labor and whatnot. For glass blowing, it's not just the back, but it's your hands, it's your wrists, it's your forearms, a lot of that. And a lot of the constant turn that we're doing when we have really hot glass on the end of the pipe, a lot of repetitive motion. So a lot of people think that burns are probably the most hazardous thing for a glass studio. And don't get me wrong, burns can be quite hazardous if you get a bad one, which is rare. But I'd say that the biggest issue with glass blowers is that their muscles, their tendons. And really, the glass is always very hot when we're working it, but we're aware of it. We're looking at it. We know the glass is hot, so it's really rare that you get burned on the glass. Metal tools, though, different story. So if you're sculpting with tweezers or you're using some crimps and you're squishing hot glass with them, or you're pulling, you're moving it around, and you are a little careless and you grab the wrong spot, or if you pick up the tool right off the gaffer's bench and you didn't notice they just used it, certainly you get a burn. This thing is coming together really, really well. Nice. Even the subtle moves that Beth goes through when she is flipping 180 degrees, if you watch when they do that, she has it upright and then lets it slump ever so slightly before Elliot makes it there. So when she flips, there's enough time for him to position it and get it before they have to flip again. And a lot of that just comes down to knowing each other quite well. They have been working together for 5 years now. Elliot has been sculpting his own glass for about 10 years. And he did work with a team of glass makers, let me get this right, for 8 years as part of the London glass blowing studio team, alongside many other very skilled craftspeople. And that's a great way to learn and develop your skill set, working with others that have been in the field and have known the material very, very well professionally for a long, long time. That's a wooden board that he's using right there to kind of press on certain areas and continue that bend and that curve. I was waiting for that torch to die down. It's pretty odd. If you want to follow any of the activity that Elliot and Beth put out there online, a great way to get into that is on Instagram, if anybody uses that. And up here we have both of their tags. So E. Walker Glass Art for Elliot. And down here is the gallery that Beth started at Blowfish/gallery for Beth Wood. And the Corning Museum of Glass as well. We post a lot of content. Amanda will surely be posting video clips and some still images of this process online through Instagram, Twitter, Facebook, Flickr. And of course, this video, the live feed right now, will be uploaded to our YouTube channel. And there's plenty of content on our YouTube channel from past visiting artists as well as our home team that has done a lot of different glass down here in the amphitheater. But you can see Helen has just been standing by, ready to go as soon as Elliot needs it, that next bit. We actually begin with all the pipes and the rods by preheating them. You guys can see our pipe rack over here. That's our pipe warmer. We preheat the ends to about 1,000 degrees, just over that. To get the glass to adhere to the rods, they do need to be preheated. And when we're done with them, in this case you can see Helen carries that residual over and sets this into a bucket of water. So as that glass rapidly cools, it does break off from the end of the rod, and we can remelt all that. Some of the stuff we don't remelt. In this case, the bits of glass that come off the end of the rod itself do carry a little bit of metal scale with it, and that can discolor the glass. So we generally don't reuse that, but anything that's clean, clear glass, we will remelt that. Did anybody else have any questions about the process? Once we have this part built and we start to add the other sections together and this gets a lot bigger, it's going to get really, really exciting. And I might be called in to help open doors or use the torch. So now is a good time to answer any questions for you. When Elliot first started up yesterday morning, we asked him if he wanted to work with any colored glass. I showed you some of the frit. He said, no, for this piece, I actually want to keep it clear. And he's thinking of sandblasting it once it's cold, which gives it kind of a frosted look on the surface. And he said he wants to go with sort of an ethereal kind of look to it for the skeleton, which I think will look really, really neat. You can also acid etch the glass. Well, sandblasting is a pretty fast thing that you can do. Just put this piece into a booth and sandblast it. Give it a nice frosted effect. And he also said, because I didn't know if he was planning on mounting this somehow with the hip bone structure that he formed earlier onto a wall or a panel, but he said he's thinking of actually just laying it together on a marble slab. We had a question online from our viewers about the size of our reheating furnaces, if we can adjust the size of that as the piece gets bigger. And in this case, the one that we're using, I mentioned it takes about an hour for it to get hot enough to use. This one has 3 sets of doors. I'm not going to open them now, but if we did open that larger set, I think that's a 21 or a 22-inch diameter. And that's certainly well big enough to accommodate the scale that we're working today. Over here, we have an assistance setup bench, which is much smaller. But if we wanted to work a really large sculpture, we would plan ahead for that, and we could light up our jumbo, which George is standing right in front of. George, would you mind just sliding those outer doors open? So we have 4 doors, and the exterior doors on that are sliders that open up, and you could fit a few of us in there. So that is a gigantic reheating chamber, which takes almost 4 times as much energy to run. So if we don't need it, we're not going to fire that one up. But the quick answer to that is we can't really adjust the size of the reheating oven because it's just a castable barrel. You could use a different one, but that one would take about 2 hours to get hot enough to use. So that's where the planning comes in, saying, what size piece am I going to make? What tools, what equipment do I need before I start off? Even the blowpipes. You know, the pipes make a big difference as well. They're working on sort of a standard medium-sized blowpipe. We have what we call cup pipes, and we also have really large, really big diameter blowpipes if we're working a really large scale. But if you wanted to make something really small, like a Venetian-style goblet or a drinking glass, preferably you'd use one of these. So much more slender, lighter weight, easier to wield and move around. It's better balanced for lighter glass work. It doesn't have a big rubber grip on there either, so there's not much in the way if you need to be nimble and move fast with it. But if you started to build something like this on one of these and you get a lot of weight on there, there's not much torque because it's so much smaller in diameter. You don't have a rubber grip, so it's harder to turn once your hands start to sweat quite a bit more. So planning ahead and knowing what to begin with, right? That's a pretty important part of it as well. But that large reheating chamber that George is standing in front of, that's one of the largest ones. I won't say it's the largest because I'm sure there are bigger ones out there, but that's one of the largest ones you'll find around for sure. And standing, I can tell you from personal experience, standing close to that one when you're reheating and you open those big doors, that gets pretty uncomfortable real fast. We actually have a screen that's mounted right there that we can slide in front of the glass maker, and it goes around the pipe. So if they're standing there for a long time, it just brings us more comfort. For this, the opening that we have going on right now, that's pretty standard. When you watch Beth standing in front of it, I'm sure she's quite comfortable. But there is a shield that we tuck behind and a little sight glass that's tinted that we can comfortably look through. There's another question about contamination with our glass, and if the glass gets contaminated, what can you do to clean it or get the contaminant out? That's a pretty broad question, and there's a lot of ways I can address it. But since we're using these pickup ovens, that's a pretty good starting point. In the bottom of the ovens, inevitably there's a bit of dust from opening the door and closing the door and opening and closing the door over time. We actually vacuumed those out yesterday morning just to clean them up. Now, when you put a piece of glass in there, if a little bit of dust does stick to it, you can brush that dust off with a little whisk broom. But if you have dust on the piece and then you soften the glass, that dust embeds itself into it, and you can't really get it out unless you were to grind it away once the piece was cold. So that's one version. Another version of a contaminant, is actually the ceramic crucible that the glass sits inside. Those pots break down over time. They're a high-fired, very tough ceramic that can withstand those temperatures for a long duration. But I mentioned earlier that the hot glass, the molten glass, is corrosive to that ceramic. So over time, that glass is so slowly and subtly chewing away at it. And we can see, if I open up that door right now and I look in there, I can see lines, I can see pits where that crucible has been chewed away. Those little pits can break off. Those little chunks of ceramic can break off and kind of just float into the glass. And sometimes you'll take a gather and you'll see one. We call them stones. And you can actually, when the glass is molten, when it's real hot, Sorry about that. Our rechargeable batteries aren't as rechargeable as they were when we first started with them. But anyway, you can pluck those stones out of the gather if you carefully do it. You can use some tweezers and kind of just dig into the liquid glass, and then cut those stones out. You can do the same thing with bubbles. When we fill that furnace full of glass, when we call that charging, you can shovel in 100 pounds of cullet, which are just chunks of glass that will melt down. And it generally melts pretty fast, but in that process of melting, you create little bubbles. And those bubbles will rise to the surface over time. But if there's bubbles in your gather, you can also pluck those out and cut them away. But those are just two different types of contaminants that I could think of in terms of the process we're doing right now. But a fantastic little spiral going on with all these vertebrae that he's been attaching one by one, using paddles. Dry wood in this case is also a really nice material for what he's doing there because it doesn't shock the glass. It doesn't pull heat from it. If we were to use those metal paddles with that tag to do this, he would have probably preheated the tag, but with the dry wood, you don't need to. People have asked what type of wood, and those are cherry wood, but all fruit woods work really well for glass making. They burn slow, they burn clean. Elliot hasn't used them for making any of these pieces, but a common tool to shape molten glass on the end of a pipe with is called a block, and this is another good reason that we use fruit woods. They're soaked in water, so you can cradle or gather a molten glass in a wet wooden scoop and shape it, but fruit woods have a really even grain structure, so as the tool burns away, it's nice and smooth. Eventually it burns down to the point where it kind of burns back and you can't effectively use it, but it burns and it keeps that really nice smooth curve to it. In this case, he is using that propane torch, that lower temperature, to do more broad strokes of heating, just in the very middle section of that spiral. If he wants to bend it in on itself or position it differently, that does some preheating. Unlike the hot torch, which would kind of liquefy one spot very quickly, but it kind of gives a broader area a little bit of life and a little bit of movement. And that's why he's using that at that moment. I think he's just sort of squeezing them in a little bit tighter. Good? All right. What do you folks think? Looks pretty sweet, right? So the next section is complete. We got to get this one into the pickup oven, and then we'll start off the final. I think he makes 2 or 3 vertebrae that this will get attached to, and then that final sort of the arch shape for the neck portion. I had a question, how often do we do a furnace deep clean? So talking about the crucibles and how they break down and stones come into the glass. That furnace has been going with the same crucible in it since 2015 when we lit it up. And it's surprising. I've worked out of furnaces that the crucibles will last about 6 months before you have to replace them. But in a production setting, if you needed really good quality glass all the time, we would have replaced that before now. But that's on its last legs. So when the time comes to replace that, we'll actually empty the glass out. So we'll work the level down, but we have giant metal ladles, and we'll have a couple big steel drums full of water, and we'll ladle the glass out and dump it into the buckets of water, empty it, and then we can shut it off and do maintenance to it as we need to. So we're coming up at that point. So George is going to catch this with some Kevlar gloves. We'll hold our applause before he gets it into that oven. Don't want to startle him. But Elliot drips a little water onto that constriction. He just crimped that line down. A nice tight line, so this should pop off with no trouble. A little water for stress cracks and a tiny little tap. Look how easily that came free. They're going to fire polish this too. When you break glass, even though it's about 1,000, maybe 1,100 degrees right now, it's sharp. So a little fire polish on that sharp edge. Helen grabs the door, and George will carefully set this one down into the bottom of the oven. All right, let's give the team a big round of applause for that. Part number 2 is complete. Then the fun stuff starts. So Elliot, do you make 2 vertebrae for this, 3 vertebrae to start the 3? And then we'll start to add the loop first, and then that final component. Very good. Yeah. Any questions that I can answer or anything for Elliot? Yeah. At what point in the process did this first one break? Right at the very end. Yep, right at the very end. We had everything assembled, and it was on the end of the handle, the punty that we were working on, and we actually had we had one pickup oven there and one pickup oven here, and we assembled the last part over here, and George went in to take a reheat on it, and he made it in the oven okay, and it stayed there for a couple seconds, but it popped off. And the connection just wasn't quite substantial enough to support all that excess weight that was on the tip of it. So it popped off. Now, a little quick thinking, we quickly shut that oven off so the burner stopped blowing into it. Because if you leave it in there, it starts to just kind of melt into a puddle. I think I had the Kevlar gloves on already because I was just sort of cradling that extra weight if he needed me there. So when we shut it off, I just reached in and I grabbed it out and I threw it in the annealer. So there's a little bit of ceramic on some of these parts. You can see it looks like kind of dusty, and that's the bottom of the reheating chambers. So there's what we call grog in there. It's almost like kitty litter, but for that oven. So if glass does fall in there, that's a high temperature material that allows you to basically scrape or pull the glass out before it does melt into a puddle. So we were able to salvage them, but that's what the dust is that's on there. But it's almost like you dug this out of a old archaeological site or something. But so this is stable because we did get it into an oven and we slowly cooled it. If we just pulled it out of that oven and set it on the ground, it would have just cracked and fallen apart into many pieces. So it has been annealed. But that's, Elliot was talking about that beforehand and talking about throughout the day. It's like you learn as you go through the process. You figure it out. This was the first one he's made. We got it assembled really nicely. He's made some adjustments to make this one much smoother, and no doubt the final connection, I'm sure this will all go nice and smooth. That's part of the process of being a glassmaker. So we'll get to see a few more of these vertebrae being made, or at least one more. I think he might have the other components, or no, this is on a smaller pipe. So this is an indicator to me. Do you notice the blowpipe he's on? I showed everybody the cup pipes, right? We're not going to build this whole thing on that cup pipe. So that's going to be one component that will go into that pickup box. That tells me that this is going to go away. He'll probably make the final one on one of the larger pipes, and then we can start to add and build everything on there. So planning ahead for that. But pardon me for just 1 second. I'm going to drink a little bit of water. Well, if anybody has joined us after our introduction here in the amphitheater or online, I do want to make one more introduction that Elliot Walker is our visiting artist for this week and part of next week. He's the one seated at the bench sculpting right now one part of a larger sculpture we're putting together. He's here with his partner, Beth Wood, working with our team, George Kennard and Helen Tegler, to put together this loop of a spinal cord, and the bottom feature of this sculpture has already been complete and is sitting in an oven to slowly cool down. But he was the winner of season 2, Blown Away, a reality show about glass blowing that's on Netflix. Netflix did not produce it, but Netflix carries it. And he was the finalist in season 2 and won that final challenge. And part of that prize package for winning was to come here for residency and create a body of work. So this is experimental work that Elliot's doing. He's been a glass sculptor for 10 years now. Comes from the UK, he and Beth, and they've been working together as partners for about 5 years now. Well, we've made a lot of these vertebrae with him yesterday and today for this sculpture, and the first run that we did yesterday on the table here. And all in all, I'm not going to count all of them, but it looks like we have about 30 to 35 vertebrae in this particular one. And these are the final ones for this particular sculpture. But when sculpting glass, using a torch like this is a very, very valuable thing. It's something that's pretty new to the hot shop, that torch using oxygen and gas, but it's something that flame workers have used for a long time. Well, have used. If anybody has seen our flame working demonstration here at the museum, they work with a different type of glass called borosilicate, and it's a higher temperature working range, and you need a torch like that to work it. But that's a different process too. They don't use blowpipes as we're using here, furnace working as we call this with big ovens, but they use rods and tubing, and they can hold on to those rods right in their hands and heat the rod up right in the flame that sits in front of them, mounted at a table. But for our purposes of sculpting glass like this, it's a great way to achieve good fine detail. You could reheat glass in that oven. You could stay in there long enough to get everything nice and soft, but then you're going to soften everything else, and you're going to start to lose some of that detail that you've sculpted in there. But all these moves that you see him doing right now, there's a lot of different tweaks and a lot of different pinches and pulls with those tweezers. And this is something that, for him at this point, it's just muscle memory, because he's made so many of these vertebrae. He's just going through the same steps. And when you figure out how to do something like this, inevitably the first, several that you make aren't that good, or aren't as good as the next ones that you do. But you learn how much glass you need. You learn how to heat the certain areas, or what pinch to make, or how much to pinch. So this one's just about complete. He'll make one more and put that one away as well. But then you'll see him make the third and final one, which will be the very base that we're going to build and attach everything to. A little bit of water. You see us do this from time to time. Drop some water on the glass. Tiny stress cracks form when you drop water on there. So we can use thermal shock to our advantage. And then that tap on the pipe is what pops the piece free. Can we roll that gathering animation? Do we have that available? Is that something that we can roll? Thank you very much. I'm not sure if it's Brad that's up there or not, but this is exactly what Elliot just did. We open up our furnace door, we dip down into that pot full of glass, and then we rotate smoothly in one direction and lift level with the pipe. That's called gathering. Now, to make these small vertebrae, one gather glass is plenty. To make a larger scale piece, you might need 2 gathers or 3 gathers or 4 gathers, whatever it takes. But that viscosity is what really determines how much you can collect or gather at one time. Below pre-shaping, he's going to form a small bubble. He blows in caps of breath of air in the backside of the pipe. That's a pretty common method. We call it blown cap. Now, it's hard to do, and a beginner struggles with that because there's a certain level of finesse to blowing and quickly getting your thumb sealed over the end before the air comes out and escapes. But we do that to pressurize the pipe so we can hold that pressure in there and pull the pipe back and look at the bubble forming. Because otherwise, you have to hold the pipe out here and blow through, and you can't really see it form. You can kind of feel it, but you can't really see the bubble form. So that blow and cap method's a nice way to do it. Takes a while to really kind of get that down, though. Generally speaking, when the glass is that hot, it's very soft. It's very easy to inflate, and a little bit of air pressure does it. But that pressure needed to start the bubble is a little bit greater because there's a kind of a barrier where the pipe and the glass first meet. That's a sort of a colder section of glass because the metal is always chilling it. Does that make sense? So there's almost a little membrane of glass that you need to pop through. So you need to start off with a little bit more pressure, but then once that bubble's there, just gentle breaths of air is all it takes. It's a tool that you don't see him use that much once he's got all these forms complete. But if we're making vessels, it's a tool you use all the time. They're called jacks. And the blades are profiled like butter knives. So we refer to the tool in the plural because there are 2 blades welded together. But beeswax on there as a lubrication. That's what's kind of burning away. You see a little smoke or a little fire. But they're really, really useful for squeezing into the glass, for contouring. Also, when you have an opening in a form and you're churning to stretch it open, you get the blades in there and you can open them up as you widen or open the lip of a vessel up a little bit further. So this is one of those very complicated applications. George is preparing the bit. to go onto the body of the vertebrae. And I don't know if there's an actual technical name for this. Some people call it a split bit. Some people call it a T-bit. But he's shaped it like a T on the end of that rod, and when he gets it hot enough and brings it straight up and down, that T droops, and then it gives us 2 points of contact onto the body of the vertebrae. Great camera shot there that Dan's getting. Nice close-up shot. So it creates like an inverted V. Now, if Elliot starts to kind of pinch the top of that to make this pinch in that section, and we don't have a tool in the little crux right there, that gap, you can squeeze those two bits together, and then you form one solid little blob. And that's not what we want. We want to have that little opening. So George goes in there with that metal rod and just kind of prevents that from happening. So he gets the rod in there and just makes sure that the gap stays there. Can you hear the popping over here? And so when we're done with those pipes, when we're done with the rods, that glass is rapidly cooling, and it does fracture, and it kind of just shears off. It kind of pops right off. We like to put those into closed, well, there's buckets of water you can put a solid rod in. You don't want to put a blowpipe into a bucket of water because that water turns to steam, and the steam will shoot through the pipe, and it heats the whole thing up. So we put the pipes into a dry bucket, but it's a closed-in bucket, so all that cullet that's basically shattering off is contained in that bucket. A couple pinches with the tweezers. And those ever-important flash heats, those very brief overall reheats. Just maintaining temperature. And that's usually the final move you see him do. When he gets all those pinches established, he heats the very top of that middle one, and he just goes in for one final little pinch with the tweezers to give it that little detail. And he's doing the same thing on all of these. So this is really just programmed into those movements for him at this point. But this tells us that he's done with it. He heats up that area where it's connected to the pipe, and he crimps it down a little bit further. So he already has a pretty good constriction established. But to help it break off with no trouble, he heats it, crimps it real tight, and then it should pop right off nice and easy. And to further help it along, he's been just dropping a little bit of water onto it. Now, if he dropped water onto any part of the vertebrae at this point, it'd crack it, for sure. So just a little bit of water onto that line. And a swift little tap to do it, just like so. All right. So that's the last one that's going to go into the box. Now he's going to build the final one that we'll start assembling all these pieces to.
Okay, so, huh? No, just let me get a little bit further through. So if we can have the knock off table somewhere around here, just so I can torch it before we go down, yeah, we'll just get that ready. We'll knock this one off.
We had a question about workability and the time frame when we're reheating something. How stiff is the glass? I'll try to answer that as best I can. When we're working something, at this point, Elliot has a fresh gather glass. He can shape this up. He can put a bubble in there. He can work it for about a half a minute or so. He'll take quick reheats to keep it nice and soft so it's easier to work and manipulate. But sometimes we'll put the piece in our reheating chamber when it is pretty stiff, once everything has really kind of turned rigid. Then it takes a lot longer to reheat. But if you watched, how long was he in the oven right there? Less than 3 seconds, right? 3 to 4 seconds time. That's because everything is still quite hot, still quite soft. But if you watch when we're flipping something around or when we transfer a piece, we might have to reheat it for much, much longer to soften it. And that's really determined by thickness as well as temperature. So the thicker something is, if it's all rigid and you want to soften it, you have to stay in that oven for quite some time and let the heat work its way into it. The thinner something is, the faster those reheats tend to be. But that's really based on thickness as well as how soft you want to get the glass. But in this case, he has pretty much all the components made, so we're not going to be really re-softening much. We're just going to be adding those bits together and maybe doing some minimal heating to bend it or contour it the way we need to, but we won't be really using that reheating chamber to generally soften the glass too much. Is there going to be a season 3 of Blown Away? I can't say. Yeah, I think we'll just have to watch and see. It comes out. But that was filmed up in Hamilton, Ontario. So where we are in Corning, it's about 3.5 hours north of us. But there's a Christmas special that's out. I asked earlier, how many folks have seen Blown Away? Show of hands, just curious. It's about half the crowd. So two full seasons, season 1 and season 2. Our team took part in the final episodes to help out the finalists. But the Christmas special was a shorter version. Our museum didn't take part in that one. What was that? Would they ever have an episode here? Don't know. Yep. The production company that did that is called Marble Media. So it's a Canadian production company, film crew that filmed it all. And Netflix agreed to pick it and carry it up, or to carry it, to pick it up and carry it. So it is available on Netflix, but it was not Netflix's show. But our museum was asked to participate in that. 6 glassmakers took part in the final episodes. So throughout the bulk of the series, there were assistants helping the contestants. Those assistants were mostly from Sheridan College. And our team went up to help out the final episodes. So we had 3 glassmakers for each finalist. So 6 of us total. But the prize package, part of winning the final, was a prize package including coming to the Corning Museum of Glass for residency. And this was a long time coming for Elliot and Beth. The pandemic hit right. We were coming back from Canada from filming right before the borders and the states started to shut down. And so his prize package was delayed quite a bit, but he has finally made it here. Will the sculpture be displayed in the museum? I don't think it will be displayed here in the museum. I can't say for sure. I don't think it will be, but this is Elliot's to take and do with whatever he wants. Yep, so the work that he makes here during his time with us, this is all his work. But for sure there will be pictures, definitely pictures, yeah. So tune into that. You can either follow Elliot through his Instagram channel, the handle that is up there on the whiteboard, or follow our museum on any number of social media channels. Amanda's over here monitoring that channel right now, the YouTube channel, the live feed that we see happening. But she gets really good video content, some really good photographs of what's happening, and she posts a lot of those on Instagram, Twitter, Facebook, Flickr. Anything else? Am I missing anything? Not yet? Not yet. It's also a great way to kind of keep in touch with what's happening, what's coming up for our museum, because there's just a flurry of activity all the time. And not just the social media channels, but our museum has an emailer as well. So you can sign up for that through our website, cmog.org, and hear about lots of fun stuff that's coming around the corner. Okay, so he's almost done with the final vertebrae. George is over here crafting a punty, I think, to attach to this. I just heard Elliot asked Helen to turn up the pickup oven. Yes, what you need. You got it. So the pickup ovens, I was talking about them earlier. They can hold glass no problem indefinitely, and the temperature we like to hold them at for this glass is around 900 degrees. But we want to turn them up before we start to pull pieces out, because if we pull those pieces out from 900, room temperature hits it, it can crack it very quickly. So we bump the temp up just a couple hundred extra degrees, and that gives us enough time to comfortably pull that piece out, attach it to the piece, and then we can reheat it, and it should be safe. Now, you might say, why don't you just turn them up to 1100 to start and keep the pieces there? If you do that, those pieces can slowly slump. They can distort at 1100, or they can actually stick to the ceramic if you stay there at 1100 too long, the bottom of that oven, the ceramic shelf. So timing with these temperatures is really important. But George is crafting a pretty specialized punty over here. It's a blown punty. Are you going to pop through that? No? Oh, this is going to be part of, it's going to be like another vertebrae section? Yep. Very cool. So has made a bubble. He's got a pretty thick bubble going on here, but he also squeezed in the beginning of a constriction. So we have a break-off line established. This is a pretty substantial punty, though, so this should hold on to the weight of this whole form through the duration. But George is now using another torch, so the same setup at both of these benches, a reheating chamber, bench with all the hand tools, and that same style hot torch that we've seen Elliot using. And George is superheating the tip of that, so I think we'll actually adhere this to the vertebrae that Elliot has. Now, in the end, once we break this, once the piece is all done, I don't want to jump too far ahead, but once the piece is all done and we break this free from the punty that George is on, there's going to be a little residual material, but that can be cold worked off of there. So if we just envision this piece that I'm holding right here, say you have that excess punty on the end, cold working is where you can actually use a diamond saw, cut it off, and then grind and polish it away if you need to, using equipment to do that. It's a different process. But there they go. They adhered that little disc, so they flipped it around. Elliot just tapped it off onto a knockoff stand. It just flipped the piece around, and then George came over and just stuck it right to the face of the punty that he made. Now we're in a position to start adding all these other components. Are you done with the stand? You don't need that anymore? I'll get that out of your way. All right, so it looks like Helen is bringing over a glue bit. So we're going to start adding another part. Elliot's actually wearing specialty glasses. Those lenses are didymium. And in terms of flame working, when you're torching glass with those higher powered, higher temperature torches, it creates a soda flare, which is an orange color. It's burning the sodium out, and the didymium filters that out, so it just makes things much clearer for him when he's using the torch. So the same steps he was going through to build that segment for the loop for our spine. Again, we have the neck portion of the spine complete. Those two components are sitting in that pickup oven that's closest to Elliot. I think we have one more individual vertebrae to add to this, and then we're going to add the loop, and then we'll add the neck portion of this. And that's where things get really interesting. It looks like George will be handling the pipe and taking the reheats. And Elliot is timing this too when he asks Helen to bring this bit over so that there's no more movement in the pieces that he's assembled. Because if there's still a little softness in that last joint and he tips it up in the air, it can continue to kind of slump over on itself. But he knows from experience the timing involved to do that. And you can see that he really kind of presses that bit on there. So that little glue bit that he puts in there, he brings that vertebrae over and kind of smashes it in there and squeezes pretty hard, and it fills that glue bit out. So it actually does create sort of the in-between sections of those vertebrae. But in that case, putting a lot of pressure on it to do so. And then a couple little tweaks.
Okay, so the loop's next.
So I think we're doing the same concept, the same add a glue bit, and then attach that loop first. So they're prepping some more space because this is going to get considerably larger. Helen opens up that medium set of doors. Helen just said there's a little bubble in this one. Would you like a new one? He said, yeah, let's put a new one. Not like it would really harm the structural integrity of it. It depends on the size of the bubble, but visually speaking, you don't want it in there. He's put all this legwork and time into this. Nice clean gather. Hands it off to George. George takes it for a brief flash heat. Grabs his gloves. The nod of the head. That's George's cue to come back to the bench. Elliot grabs the piece. One shot. Really works it on there, making sure it's got a really good contact. And a quick flash. What do y'all think? Pretty nice. It's a nail-biting moment. The next one is the real nail-biter. So now, it gets pretty challenging for George because that glue bit that they just added, that's still pretty soft. That bit can move around a lot, but George needed to get it into the oven for that flash heat. And so Elliot's saying, okay, let it just kind of slump where it is. But now Beth can use this torch to heat that, just to keep it warm enough so nothing breaks. I had the gloves on just in case. It wasn't because my hands were cold. Those larger pieces and the gloves that Elliot's using, they're a little thinner than these, and those larger ones, you can feel the heat go through them a little quicker. So I was just standing by in case he needed a little extra support on that. So one more link that doesn't have a loop like that, but just a nice subtle arch to it will be added. This piece is going to get quite a bit longer. But this is only one section of the final sculpture. The first section we did earlier today, right when we came back from lunch, there's a couple of vertebrae, but it's the hip bones to the sculpture. And those have all been assembled, and they're sitting in the oven that this piece will go into for safe and slow cooling. And the annealing time frame, the slow cooling time frame for this piece, we'll probably put it on at least a 16-hour cool down. The thicker something is, the longer it needs. These are all blown components, but there's a lot of connection points. And so just to be safe, we'll probably put it on a little bit of a longer profile. So he's just getting that nice continuous curve from that first part that he was building onto, adding that spiral, really just making sure that it has a nice flow to it. And I think he's happy with it there. So now, once he gets it in position, the name of the game is to really just kind of keep all the temperatures just right, but let that position solidify. Let that turn rigid in that joint to stop it from moving. So brief, quick reheats using that torch. But you can see how much torque he's got to apply now, right? Every time he flips that up or down, all that offset weight working against that. Part of the reason we're on a larger blowpipe, part of the reason we have the grip right there too. That grip helps out a lot. You can see the way that Beth is torching right now too. She's torching the punty, the glass that's on the actual blowpipe. So the last part to enter that reheating chamber and the first part to exit every single time is the punty, is that section. And the metal is always pulling heat out of the glass. So you want to be able to keep that area warm enough so it's strong enough to hold the weight of the piece. So especially when you start to sculpt and add components like this and work for a longer duration, you keep that section warm enough and using that torch to do so. All right, I think he's happy with it. I just heard him say it's great. But he's just giving George some guidance what to look for. Because you do actually want to keep a slight amount of movement through parts of that in this process. If there is a little movement, that's kind of a safety net. That lets you know that the glass is still a little bit soft and it can handle the weight that you're putting onto it. But in that movement, you don't want it to get out of whack in terms of the shape or position that Elliot has established. So just kind of giving George a couple pointers as to what to look for as he's heating. Probably talking about the position he wants him to hold this in too when they go to add this final component. All right, here we go. Helen's gathering up. But each time they're adding these bits, they're doing so and to make sure that that surface area they're dripping on is as level as possible. And that's why he makes all those angle adjustments. Just so the glass doesn't spill over the edge of the vertebrae they're attaching it to. On your left, Dan. Raise your hand if you're holding your breath. You're right to do so. It's looking fantastic. We'll hold the rounds of applause now until we get this piece put away. I think I'm safe to take the gloves off for a moment. So I'm assuming he'll probably position this a little bit, make sure that it has that nice flow, that continuous curve from that segment we just joined to. But once he has everything in the right spot, then we got to balance the temperatures of everything. That's where you really want to make sure that those softer joints lose their heat and stiffen up, but you keep everything else warm enough so nothing cracks. And that in itself is an art form, learning how to get the temperatures just right. I was talking with Elliot before we started this piece too as to how he would like this loaded in our oven, and he actually set up a little kind of a bed of fiber fracks in there for the loop section to set into nicely, so we can get it in there gently. But a lot of delicate components on this beautiful sculpture. What you think, Elliot? Don't know yet? All right. I'm just standing by. I'll throw the hoodie on. I'm going to be the one that loads this piece, so get half my gear on now. George is being really careful every time he heats. You can see he's continually turning. Sometimes he pauses or switches directions. But he's looking right in that oven, and he's watching the way that this piece is moving. Anywhere it's been softened, he can see it bend this way or that. So whatever position it's handed off to him in, he's trying to maintain that position. He wants to let Elliot do all the shaping or the adjustments. And the longer you stay in the oven to take those necessary reheats, you know, the more it starts to move around. But you hear him sometimes saying, okay, flash. Flash is just that very brief maintenance reheat. And Helen's being great with the doors too. If you open all the doors on that oven, the heat drops considerably and it throws the rhythm of how to flash off. So if the oven gets a little too cold, then that's detrimental to the process here. So closing up the wide set of doors each time they go in and out. I think they're getting close. We'll probably see Elliot, once he's done, score that final punty a little bit more. He did this throughout the process with all the other elements too. He would torch that section to soften it and kind of crimp it down with a tool, either a pair of shears or the sharper edge of that tag tool, but just making the constriction nice and tight. So all you have to do is just give it a little tap on that rod to get the piece to pop off. You good? All right, I got the thumbs up. That's my cue. Let's open both doors. Yeah, just, yep, the left and the right. Nope, the outer handles. Yep, so you pull them towards you. Yep, and then swing them open. Let's do both, because I'm going right in the middle. Yeah, thank you. Yep, so now this torch you use just to really soften that one section. This maintains the shape in the piece, so we don't have to overheat it, but getting that area nice and soft. And George will be able to feel it start softening. He'll have to apply a bit more torque turning that pipe as it softens. And then we can start to score that. And I like to get the gloves under when they do score this, because that's a lot of weight on that piece. And even though that punty might be soft, scoring it can weaken it quite a bit. And just in case, I'll hold the gloves underneath. I imagine we'll take at least another heat after this, though. Oh, I guess we're going now. I got it. There we go. Thank you. All right, yeah, let's give it up for the team. Huge round of applause. That's Elliot Walker, Beth Wood, our home team, George Kenner and Helen Tegler, Dan with the video, Amanda with the content online. Fantastic job. Let's hear it one more time for our glassmaker. That was a fantastic demonstration. Great way to finish off a very strong day in the hot shop. Folks, that is going to conclude our program. I want to thank you all very much for joining us. I want to thank everybody for joining us online as well.